Yeah, I'm Dr. Ella Gilbert. I'm a polar climate scientist at the British Antarctic Survey, and I spend all of my time thinking about how the Arctic and the Antarctic are currently and how they're likely to change with future climate change. Yeah, PolarRes is a really cool project. It's an EU-wide, EU-funded project which brings in partners from all over Europe. And that means we have loads and loads of different people working on the project with all their different kind of expertise. But basically, the idea of the project is to predict the future of the Arctic and the Antarctic and try to understand how the physical changes that we expect are going to translate into real on the ground impacts. So things like how wildfire risk might change in the Arctic, or how the loss of sea ice will affect shipping, or how it will impact the fish that we can catch in the Southern Ocean around Antarctica. Basically, translating what might happen in the physical system, so the atmosphere or the ocean or the ice sheet, for example, and turning that into a real kind of human impact for people who actually live in those places. Yeah, so the main tool that we use for this project is a climate model. And this is the same sort of idea of the way that we predict the weather. So if you ever use a weather forecast or you check your phone to see whether you should be taking an umbrella out to school or work with you, then you are using the product of a model. And basically, all this does is it kind of takes information about how things are right now in the Arctic or the Antarctic, and then it kind of churns them up. There's a whole bunch of mathematical calculations on them, and then it can tell us what is likely to happen in, it could be a week, it could be a year, or in our case, it could be 100 years from now. So it's a really amazing tool that allows us to imagine what the future will look like in the Arctic and the Antarctic. Yeah, so the Arctic is the canary in the coal mine, really, and it's warming two, three, maybe even four times faster than the rest of the planet. The work is kind of still in progress, but it looks like the Arctic is likely to see much more warming as we go into the future, and that's going to have impacts on things like the number of wildfires that we see, the amount of permafrost, which is permanently frozen ground that gets melted. This is going to have impact on the people who live there, on the animals and the plants that make the Arctic their home as well. And then in the Antarctic, it's a different kind of question, different kind of problem. Nobody lives there permanently. There aren't lots of settlements or towns that are down there, but it's also seeing huge amounts of change even already, and that's likely to continue in the future. The thing about the polar regions is that they are at the forefront of climate change, bearing the brunt of lots of those changes because ice melts when temperatures rise. It's very sensitive to that. But also in the Antarctic, have huge amounts of ice, and it takes quite a long time for that ice to kind of start to respond to climate change. So it seems likely that we're going to start seeing that response picking up the pace as we go through towards the end of next century. Oh, I've been very lucky. I've been to both the Arctic and the Antarctic. I'm a modeler, which means I mostly sit at my desk, unfortunately, using these computer models to help us predict the future. But it does occasionally take me down south or up north. And when I do go, it's often to look at atmospheric processes. When I've been in the past, it's been to collect observations using an aircraft. So we basically fit lots and lots of different sensors onto the aircraft, and we fly in areas that are really important or very sensitive to try and understand how the atmosphere is interacting with, for example, ice in the Arctic or the Antarctic. And also, I'm a meteorologist, so a weather person by training, which means that I've also done kind of weather observation stuff as well. So, releasing weather balloons or making sure that the collection, the data that gets collected by our automatic sensors is correct, and making manual observations, things like literally looking out the window and looking at the clouds and writing down what they are, which is my dream job. Two things, I think. When I was, I guess, probably middle school age, actually, like 12, 13, I first kind of learnt about climate change, and it filled me with so much anger because it just felt so unfair that some people were bearing the brunt of climate change when it wasn't their fault for causing it, and that we had the tools and we knew what we needed to do to stop this thing that was clearly bad from happening. That kind of ignited the fire in me, if you like, and I decided pretty much then and there that I wanted to do everything that I could to be part of the solution instead of part of the problem. And then the second part was when I got to university, got to my second year, and that was when I discovered meteorology. Before that, I had never thought about the fact that you could do weather science and that that was a job. But when I discovered that and I started trying it myself, it was, yeah, a falling in love experience, and I've never looked back.